In this lesson, you will solve problems using Pythagorean theorem. And Pythagorean theorem states that if A and B are measures of the legs of a right triangle and C is the measure of a hypotenuse, then you can take A squared plus B squared to equal C squared. So what that means is you can take the leg measure squared plus the other leg squared, and that will equal the hypotenuse. And you'll also determine whether a triangle is a right triangle or not. So just to show you, Pythagorean theorem is very, very famous in mathematics. In fact, there are many, many, many proofs of Pythagorean theorem as we go through. And Pythagorean theorem is used not only in algebra, but also in geometry quite a bit. So it's very important that you understand this concept. So this is what Pythagoras looked like, Greek mathematician who discovered this, and so he got to name it after himself, and it's called Pythagorean theorem. So this is a leg of a right triangle, this is the other leg. The two legs together make that right angle, and then this is what we call the hypotenuse. So the hypotenuse is the side opposite the right angle in a right triangle, and we always will identify the hypotenuse as C. And then the legs are the sides of a right triangle that form the right angle, and we can always denote them as A and B, and it doesn't really matter which one is which. If you go A is the height or A is the base, either one is fine. So this is just a image to help you remember that this is the hypotenuse. It's a hippo lying on the longest side, hypotenuse, get it? Funny. And here's another one just to remind you. So you always remember that longest side is the hypotenuse. So if we know a right triangle has one leg of 8 and one leg of B, then you just plug this into the formula, A squared plus B squared equals C squared. So that would be 8 squared plus 15 squared equals C squared. So we do our order of operations, we have to do exponents first, so that would be 64 plus 225. And when you add that together, you get, let's see, 289, is that right? Okay, let me double check. And when you then take the square root of each side. When you have C squared, you have to take the square root to find out what that would be. If it doesn't work out as a perfect square, then what we're going to do is round it to 2 decimal places, and we'll do that on every problem. So I do 289 square root, and that works out to be 17. So my longest side is 17, so I could just say C equals 17. Now in this case, I'm missing a leg. So as you notice here, I have the hypotenuse squared. So I have A squared plus 10 squared to equal 25 squared. I don't know what A squared is, so I'm going to leave it as A squared, but I do know 10 squared is 100 and 25 squared is 625. So I subtract 100 to get this A squared by itself. And when I take 525, the square root of it, A is equal to 22.91. And since it was not exact, I can just change that to a little squiggle squiggle. 2 decimal places if it is not going to be an exact perfect square. The Pythagorean triples are whole numbers that satisfy the Pythagorean theorem. So some common triples are 3, 4, 5. A 3, 4, 5 is always a right triangle. 3 squared plus 4 squared equals 5 squared. So any scale factor of this, like a 6, 8, 10, a 9, 12, 15, any scale factor of that would also be a Pythagorean triple. Some more Pythagorean triples that we have a 9, 12, 16. That is always going to be a right triangle, a 9, 12, 16. And a 5, 12, 13. And another one would be any scale factor of those. So I'll put a few in your notes for you. So when we want to find the area of this triangle, what we have to do is find this missing leg first, and we'll call that B. So I have 12 squared plus B squared equals 20 squared. 12 squared is 144, and 20 squared is 400. I'll subtract 144. And I have B squared is equal to 400 minus 144, which is 256. Take the square root of each side, and when I take the square root of 256, I get 16 for B. Now, we did the Pythagorean theorem to find that. I want to show you one thing real quick here. This is corresponding to a 3, 4, 5 Pythagorean triple with a scale factor of 4. 5 times 4 is 20, 3 times 4 is 12. So you would have known that this is 16 if you remember that this is a 3, 4, 5 with a scale factor of 4. So you can use those Pythagorean triples as shortcuts if you wanted to. So to find the area of this triangle, I'm going to do half of base times height. The area formula for a triangle is half of base times height. So half of 12 times 16. So I just do 16 times 6 and I get, sorry about that, 96. So I'll say A for area is 96, and in this case I don't have any units, so I would just say units squared. So you will have to use Pythagorean theorem to help you solve problems like area. The last thing that we're going to talk about is a corollary. It's a statement that can be proved using the Pythagorean theorem. And so what we're going to try to do is prove if this is a right triangle or not. And the first number is always going to correspond to one leg, the middle number is always another leg, and the last number is always going to be the hypotenuse. So we're going to take 20 squared plus 21 squared to see if it equals 29 squared. If it does, then we will say, yes, this is a right triangle. If it does not, then we will say, no, it is not. So this is 400 and 441. And 29 squared, I should just work it all out as we're going here. 29 squared is 841. So when I add this together, I get 841 equals 841. That is a true statement. So we would say, yes, this is a right triangle because Pythagorean theorem worked here. 8, 10, 12 would be 8 squared plus 10 squared to equal 12 squared. That's 64 plus 100 to equal 144. Well, 164 is not equal to 144. So we would say no, and this is our proof that it's no. It would not be a right triangle because it does not satisfy the Pythagorean theorem.